Welcome back to the Explainer. If you're building scalable enterprise systems or, microservices, you're well aware that keeping your codebase clean over time, it's basically half the battle. Today, we're diving deep into a concept that essentially acts as armor for your core logic. We're talking about hexagonal architecture. And specifically, we're going to look at how it actually functions inside a Java Spring Boot environment. So, have you ever experienced this absolute engineering nightmare? You decide to migrate your database, or maybe you just need to swap out an external API, and suddenly, bam, completely unrelated business rules just start breaking. You pull up your architecture diagrams, and it's just this massive, messy web of arrows pointing literally everywhere. Well, why does this happen? It happens because frameworks and external dependencies have a nasty habit of leaking into every single layer of your application. Your testing becomes incredibly painful, and your business logic, it basically becomes indistinguishable from your infrastructure. We really need a way out of this tightly coupled trap. Okay, let's dive right in. First, we'll diagnose the layered architecture problem. Then, we'll introduce the hexagonal paradigm shift and break down the core concepts of ports and adapters. After that, we'll actually look at a real Spring Boot project structure, and we'll wrap up with the major benefits and specific use cases.
All right, part one, the layered architecture problem, or when frameworks take over. Let's look at exactly why the traditional top-down approach is failing modern, complex enterprise systems.
In a traditional layered architecture, you've got your controller talking to the service to the repository, and the repository going straight to the database. The dependencies flow strictly downward, right? Which means your core business rules, the stuff living right there in the service layer, are fundamentally dependent on the database underneath it. It's totally framework-driven. Now, if you look at a hexagonal design, the dependency flow is entirely inward-pointing. Adapters talk to ports, and ports talk to the domain at the center. The absolute key here is that the center depends on absolutely nothing but itself. Let's make this tangible. Take a look at a standard Spring Boot payment service class. Just by using an @AutoWired annotation to pull in a payment repository right inside of it, you're proving your core logic is permanently chained to your infrastructure. So the crucial point is this. Your business logic now depends directly on a Spring Boot-specific injection and a database repository. If you want to unit test this service, you actually have to mock the database. And honestly, that's the exact trap we want to escape. Moving on to part two. Enter hexagonal architecture, the paradigm shift. This is the architectural solution specifically designed to isolate your core business logic from all those external systems. You'll often hear hexagonal architecture called the ports and adapters architecture. It was introduced by Alistair Cockburn with one very specific goal in mind: to protect your domain and business logic from external dependencies. It pulls this off through a principle called dependency inversion. In this model, the application core should never ever depend on frameworks, databases, or third-party APIs. Instead, all of those external systems must plug into the application core. There's a really brilliant analogy for this. Think of the domain as a phone charger socket in the wall. Different adapters can connect externally without changing the core. Think about it for a second. When you travel internationally, the socket in the wall, that core power source, it doesn't change, right? You just bring a different adapter to bridge the gap between your specific device and that universal socket. Hexagonal architecture does the exact same thing for your code. External systems, like REST APIs, Kafka streams, or databases, they simply plug in through standardized ports. Part 3. Core concepts, ports and adapters. Let's deconstruct the hexagon and look at the specific components that make this whole architecture function. Now, what's really interesting about this concept is how clearly the conceptual architecture maps onto actual Spring Boot elements. You have inbound components, which drive the application, and outbound components, which are driven by the application. An inbound port is really just an interface defining a use case, and its adapter in Spring Boot, that would be a REST controller hitting that endpoint. On the flip side, an outbound port is an interface defining what the application needs, like a repository contract. The Spring Boot adapter for that is the actual JPA repository or Kafka consumer that implements the contract. So basically, ports are the rules, and adapters are the tools. Part 4. Spring Boot project structure. It's time to build the blueprint. We're transitioning from abstract theory to practical application to see how all this maps into a modern IDE setup. If you were to open your IDE right now, a truly clean package structure starts at the very center with your domain folder. That contains pure Java models, services, and port interfaces. Surrounding that center is your application folder, which handles specific use cases. Then on the outside edge, sit your adapters, which are split neatly into inbound controllers and outbound persistence implementations. All of this gets wired together by your config package. The beauty of this is that the domain sits completely safely at the center of the hierarchy, totally isolated from the chaos of those outside edges.
Let's look at the actual code for this, starting from the inside out. Take an outbound port, for example. It's literally just a simple Java interface, a public interface called payment repository port, with a method to save a payment. Notice how there are 0 Spring annotations here. There's no mention of SQL or MongoDB. We're defining the contract first. The domain is strictly dictating what it needs from the outside world without caring at all about how the outside world actually gets it done.
Next, we step into the domain service itself. This payment service class declares a private final dependency on that payment repository port we just looked at. And this brilliantly illustrates the whole point. This domain service is completely free of Spring Boot annotations. There is no @service, no @autowired. It is pure, highly testable Java code. It relies entirely on the interface contract. Because of this, testing this core logic is incredibly simple and requires literally 0 framework overhead. Finally, we step to the outer edge of our hexagon, the adapter. In a payment repo adapter class, we finally see our Spring Boot annotations, like @repository. This class explicitly implements our pure Java payment repository port. Essentially, this adapter does the dirty work of actually talking to the database using the framework's tools, but it completely fulfills the contract demanded by the domain. This perfectly finalizes the dependency inversion, seamlessly linking the framework to the pure domain without the domain ever knowing a thing about it. All right, our final section, part 5, benefits and use cases. Now that we understand the actual mechanics, let's evaluate the real-world impact and figure out the appropriate scenarios for deploying this pattern. The benefits of this architecture are absolutely massive when it comes to long-term maintainability. First off, you get true framework independence. Your core just isn't married to Spring Boot. Second, you get vastly easier unit testing because your domain has exactly 0 external dependencies to mock out. You get cleaner business logic that is super easy to read. You also get seamless external integrations. Whether you're dealing with Kafka, REST, or gRPC, you literally just write a new adapter. And finally, you get much better microservice scalability because the boundaries of your application are strictly enforced. To put that resilience into perspective, imagine you need to switch your primary database from MySQL to Postgres. In a traditional layered architecture, that migration often bleeds right into your service layer. But in a hexagonal architecture, you just swap out the MySQL adapter on one end and plug in a new Postgres adapter in its place. Your domain code remains 100% untouched. You don't have to rewrite or even retest a single line of your core business logic. How cool is that? Of course, engineering is always about trade-offs. So here's a pragmatic checklist for when you should actually use this. Hexagonal architecture is best for large enterprise systems, complex microservices, and domain-heavy applications, where the business rules are intricate and really need to be preserved over many years. But you should absolutely avoid this for small CRUD apps, very simple side projects, or quick prototypes. For those, the strict separation of ports and adapters is honestly just unnecessary boilerplate and overhead. Always pick the right tool for the job. We'll wrap up this explainer with a final, slightly provocative thought. If your framework died tomorrow, would your business logic actually survive? If you're using a tightly coupled layered architecture, the honest answer is probably no. But if you've mastered hexagonal architecture, your pure, pristine domain logic will outlast any framework, any database, and definitely any passing technology trend. Thanks for joining me on this deep dive into software design, and keep building systems that are truly built to last.